Statistical inference is using sample statistics to make inference about the general population. Statistics is facts or characteristics about a population or a sample. Now, majority of the time, great majority of the time, when we say statistics, we will be talking about sample statistics. Population parameter is simply a population statistics, typically a number. The basic picture you want to keep in mind whenever you do statistics is you have a population that we're interested in, say the income of people of San Francisco. Now, in that population, we have the average income, we have the standard deviation of the income, or we have the proportion of income. For example, what proportion of people in San Francisco are low income or at the poverty or under the poverty line, etc. These, remember, keep in mind that these can never be observed directly. We never really know what these are. We never know what the average is. We never know what the standard deviation, and we never know what the true proportion is. Okay, but we would like to know. We would like to have an idea and try to estimate what they are. So what can we do? Well, we can select samples. So we can have samples. We can collect a sample, right, of sample of size n, and from that sample, we can calculate the sample statistic, x bar, s, right, p bar, and so on. Right? When you Google anything, when you Google, you get census data. When you get IRS data, all of those are sample statistics, and we're trying to get an idea of what the true population parameter is. The sample that we do select has to be random. Okay. Now, what does random mean? Random has to satisfy these two conditions. One, each element is selected from the same population. So if we're talking about income of people in San Francisco, then every person we select has to be from San Francisco. Second, each element is selected independently. Now, what does independent mean? So remember from chapter 4, A and B are independent if the following is true. The probability of A given B equals the probability of A. What that means is given that B happened, or given that you observe B, it doesn't change the probability of getting A. All right. An example of this would be, let's say that I'm selecting a sample, and I just stand in front of one Starbucks, and I survey people walking out of that Starbucks. Okay? Now that is not a random sample. Why? Because if I ask one person and I ask their income level, then because the fact that they're all going to the same Starbucks, right, then it changes the probability of the likelihood that I observe a second person with their similar income level. Right? So that would not be independent. Okay? So random sample is going to be really essential, right, for everything else that we are going to do. Now, once we have that sample, right, then one of the things we like to do is use it as construct an estimator. So our sample again here to xn, and suppose that we like to estimate the population average. Okay, now which estimator should we use? Now, for most of you, probably say, well, we just take the average, right? We take x bar, we take the average of this whole set. But let me propose this. Suppose, let me introduce this estimator, right? How about this, x1? What does that mean? That means, if I give you this instruction, that just means you will ignore everything else. You would just use the first. You would just use the first observation. Now that seems like a ridiculous estimator, but this is not a wrong estimator. Like this is this is just a rule that you could go by. Right? But of course, we don't use that one, right? We use this other one that all of you are very familiar with, right? We just add it to xn, right? Divided by n, and this is the most widely used one. But what I'm trying to emphasize here is that estimators is just a rule. Right? It's just a formula. Right? It's just something that you give to people and tell them what to do with a set of data. Okay, that's what an estimator is, and there is nothing wrong. Right? There's nothing mathematically wrong with using this estimator versus this one. Although this one is not as good as this one. Right? The second one is a lot better, and in fact, the second one is the best one that we know of. So we actually give it a name. We call it X bar. Right? Okay, and later on, right, we'll talk about why we can say this one here is better than this one. Okay, so that's what an estimator is. It's just a set of rules. Okay? An estimate, right, is then when we take that set of rules and we apply it to the set of data and we get a number. Okay, that's the estimate. Now there are two types of estimates that we will be producing. Right? One is the point estimate. So these are the ones you're familiar with. Right? These are just simply a single value, right, from the sample data. Okay, and we will use that to be, is intended to be close to the true population to population value. Okay, so how do we for example, right, to estimate mu, right, we use x bar, right, to estimate here two, all right, to estimate p, we use p bar, right, and so on, right. And this will give us gives a one point estimate. However, we would like also to do an interval estimate, right? So interval estimate will be something like this. You can, for example, what is the average? Well, I estimate the average to be between 23 and 54. I'm just making these numbers up. Right? So that would be give you an interval estimate. Right? An example would be imagine you call Comcast and the guy gives you an estimate of his arrival time, and he tells you that he'll be there sometime between 1 o'clock p.m. and 8 o'clock p.m. Right? That is an interval estimate. Versus if he just tells you that he'll be there at 5, right? That will be a point estimate. Okay. Now, just because he tells you he'll be there at 5, it doesn't mean that he'll be there at 5. Right, he could be there. What are the odds that he's actually there at 5 o'clock? And so by giving an interval, you're able to, in a way, give more information, because now you have a range, right? Now you have this range, and if the person or if the interval is very narrow, then it conveys a sense of accuracy or confidence. Right? The more narrow the interval is, right, the more confident it seems.